Ladies and gentlemen, welcome back to another live stream. So this is part 2 of our series of trying to make a hardware accelerated video player using Vulkan video Q extension and like FFmpeg obviously, and using libplacebo 2 on Windows, though obviously this should be cross-platform, but we're working on Windows because it's pretty much the hardest platform to get working. Linux should be very easy to test, pretty much. In fact, it might be already working on Linux at this point, right? So yeah. And as you can see here, my video player is working right here. Currently, it doesn't have any sound that we made in the previous video. And as you can see, there's the video decode right there working because it's using the GPU, not the CPU. As you can see, my application doesn't use any kind of CPU. In fact, I mean, not to that degree, but still, it's very little, pretty much. Okay, right. Anyways, I'm not sure where's the application here. I think it's probably this one, I would guess. But weird. Yeah. Anyway, so I'm gonna share my, and also it does support like HDR and stuff like that because we're using libplacebo. All right, so I'm gonna share the stream on my server really quickly, and let's go live, and let's pop out the chat, and yeah. All right, so this is the current code we have right now, and I actually have pushed it into GitHub, though for the DLLs and stuff, and like the big video, I included all of those too. But I used get LFS. In fact, this is the first time I've ever needed to use get LFS. I just got like a error that the files were too big for get, for a regular get, so I used get LFS. Obviously, I used AI to set up that, but it was just like, you know, install get LFS and do some weird stuff. Anyways, that's quite a bit of progress. Yeah, Masin Moha, welcome to the live stream. Welcome back. All right, and as you can see, there is a release here that is Windows that you could try, but obviously, I mean, like my computer is very new. Like I reset it like every single day, almost, right? So every time I switch between Linux and Windows or something. But you never know. I can't really guarantee if my computer is like virus free. But yeah, either way, the release is here. You could get it if you'd like to try it. Yeah, or as a whole 91 megabyte. Yeah, and this is something I wanted to actually tackle maybe in this video. So it is 91 megabyte because, in fact, let me download it. And let me show you what's inside of that. Hello, Theo Paris. Welcome back to the live stream. So, libplacebo actually bundles with it like a whole compiler, like a whole shader compiler. It's like bundles shader C. So alone it takes like around, I don't know, 6 megabyte or something. SDL3 also bundles all sorts of crap with it that we're currently not using, that we could indeed like brush up on if we build our own SDL. Using CMake, and also FFmpeg, same thing. We're not using most of FFmpeg, so if we do our own build, then we could take it even smaller. And yeah, and libplacebo includes a lot of things. It's not just a regular video player that we got here. Like just using this little code that we have made so far, using libplacebo and FFmpeg, we have made kind of like, you could almost say, a production grade video player, because libplacebo like handles a lot of cool stuff for you. It handles like you know, upscaling of videos. It handles HDR. It handles Dolby videos. It handles all sorts of crazy things for you, essentially. That if you would have to make by hand, it would be a lot. Though I am thinking of just like writing my own, or like just obviously making the AI write a raw Vulkan backend instead of using lip placebo, but we'll see about that. I'm not sure yet about that part, because the problem with lip placebo is that it kind of helps us and limits us in the same time. So that's the problem, kind of like frameworks and libraries that does a lot of things in general. So the nice thing is that you get very easy GLSL shaders. So because like in fact this render is being used by MPV, right? MPV video player. It's exactly the render they're using. And in fact, even FFplay recently, they started using lip placebo too for their rendering part for Vulkan. Right? And the thing is, there's actually a niche community around this MPV kind of renderer. Like for example, there is a Naruto, not Naruto, what is it called? An anime 4K. So for example, there's this anime 4K. So this is something I didn't knew before. I was just kind of like researching in the day, like today. And I found out about these kind of like niche communities that uses these lip placebo shader stuff, right? And one of these is anime 4K. This is like the most important, the most popular one. A high quality real-time upscaler for anime video. So this was very interesting because like the regular video players, what they do is that when you have, let's say, a 4K monitor and a 1080p video, it just does a regular upscaling of the video and it kind of looks too blurry, right? Or it even looks pixely if you're using like instead of bilinear or Langco's or whichever it's called, you're using like nearest filter. But here, this is an interesting upscaler because it does some math and algorithms and stuff in the shader to basically upscale, to detect first of all like the lines of the anime and all sorts of things, and kind of like upscale it in a more sophisticated fashion that it kind of looks more like it's 4K instead of just a 1080p video upscale to 4K. Obviously that would be it would give you a much more perceptible result, like if you basically, what can I say? Like you have a very low resolution video and you have a very large monitor. And that's where you're gonna see a whole lot of difference. And also one of the things that I've noticed in this community or this niche is that people couldn't find, at least from my research so far, they couldn't find a way to kind of like bake this algorithm. So basically what they want, so what this solves is that it's just the real-time part of upscaling an anime video, right? So in real time while you're actually playing the video. But what they didn't solve is, here's my video and I want to get an upscaled version baked in. Because the thing is about the real-time version here, the anime 4K shader way, is that it requires a decent GPU, right? And it kind of like consumes way more GPU than a regular upscaler, right? So what you'd like to possibly do is to just convert one video from, let's say, similar. I mean, you might have already like noticed some videos on YouTube or whichever where you like got an anime that is like in 720p or like 480p, especially the ones that are old, and then suddenly find a video on it online that is upscaled and it looks pretty cool. Yeah, there could be some tool. I haven't really found a good tool that is offline so far, and that might be an interesting niche that we could fill with our player. And yeah, so the way, there you go. So here's like bicubic, and here's like FSR CNNX, anime 4K, waifu 2x, and yeah. So these are like all the upscaling stuff. Now, this is actually not that sophisticated still, right? So there's even more sophisticated ones that actually uses like, what is it called? It uses AI. So it uses AI inference, not like the cloud AI like Gemini or whichever, no. I mean, just like an ONX model that you run in locally, it's a very small model that kind of does the upscaling for you, essentially, kind of like I guess DLSS or whatever. But yeah. But yeah, that was very interesting to me. And so what you do is you basically kind of like grab this GLSL shaders right here, and you just take them through like the lib placebo shader stuff, and it just works. Look at that. But yeah, all right. So that's that. So for today, what we're gonna do? Okay, so I think it already have downloaded the release. Let me see what's inside of it. There you go. So it contains like the DLLs of FFmpeg, which is alone 220 megabytes because it includes everything. And then actually there's more. There's the SW resample and SWS scale. Though honestly, it's too big for 200 megabyte. What the hell? Really? Yeah, I mean, apparently it's what? That's honestly strange. I would say that's too much. Not sure why that's the case. I mean, like the original one, was it that big? Hold on. I need to check this out. I didn't really pay too much attention to this. Let's see. FFmpeg full build. Where's the download that we've done yesterday? There you go. Bin and yeah, it's that big, bro. Insane. But yeah, it includes all codecs essentially. All codecs. AV codecs, AMD AV filter seems to be the main bloat cause. Yeah, it's very, so if we want to take it down, we basically need to like, you know, recompile FFmpeg ourselves at some point and then just remove stuff that we're currently not using. But yeah. Yeah, what else? Hold on, let me go back. Also, another thing, I made the project GPL3 for now, because the current build I'm using is GPL3. It includes literally everything. I mean, you could just include the components that are only LGPL, and then you can make your project LGPL, but the current build that I'm using is GPL3. So we're just going with it anyways. I mean, it's open source, so yeah. Alright, so yeah, let's go back to that folder, fine, and let's see what's up. And lib placebo alone is like 6 megabytes, SDL3 is like 4 megabytes. So like if you want to make, let's say, you know, Windows only like video player, you could make this way smaller by just using like D3D11 and the native decoding API of Windows of D3D11 and stuff. And for instead of SDL, you could use Win32 directly. It's not really that bad, at least not as bad as Wayland. But yeah. All right. So yeah. Okay. So what we're gonna be working on today. So far, this is what we got. You just like launch the program with a path to the video that you want to play, and you just get the video that you want to play. And yeah, last thing we tried to get right or to get working is audio, which didn't actually work. It was having some trouble, and I'm not sure why that was the case exactly, but it tried to do too much too soon. And you know, AI, so dumb, you gotta go with it like baby steps so you could debug along the way on what's going on. But honestly, I think I'll try, the next thing I'm gonna try is to make this like thing multi-threaded first, because like currently we're decoding the video while we're trying to render like in the main thread, which really sucks, especially after we're gonna try to like decode the audio too and the video, because currently what we're doing, let me see if I can find the player here. Alright, so you basically got this kind of like loop right here, and you got this next frame, this kind of like iterator thing. And this iterator thing, what's happening is that you say AV codec receive frame, so you grab a frame I think, from the decoder, and then you read a frame from the demuxer. So basically you got the demuxer and you got the decoder. You got like the container formats like MP4, MKV. All of these are just container formats, and they just bundle the actual bit code of the video and audio streams. And those audio and bit and video streams that are encoded there, use then a decoder for it. So you use a demuxer to kind of like unpack a container, like an MP4 container, to grab the streams that are inside of it, the metadata that is inside of it, how big it is, the duration, etc. And then once you got some packets from each video or audio stream, then you got to use the decoder for that particular package of audio or video, depending on which decoder has been used for that. But yeah. All right, so here we read a frame, and this frame or this packet that we got here could be audio, could be subtitles, could be video, doesn't matter, right? So there's some state machine here to basically the fact that like you don't necessarily get like one packet for each, one packet for each decoded frame, right? You could get like, for one packet, you could get multiple frames, or like for one frame, you could get for multiple packets, you could get one frame, and so on. So this kind of like essentially the state machine right here. This is what's going on right here, kind of essentially. And what else we got here? We also check in which stream this is. So is this the audio stream or the video stream? Currently, we only have one stream, which is the video stream. And if it's not the stream that we're interested in, currently what we do is we just throw it in the trash. We unref it, because like FFmpeg is using, I think copy on write. I'm not sure. But yeah, so like you got reference counting, and I think maybe you could basically like increase the ref count and then just write into it and stuff like that. But yeah, and then we just continue, and then we send that packet into the decoder, to the right decoder for that particular stream. Currently we have only one stream. Okay, and yeah, that's basically it for that part. Currently we only have a rewind, which goes back into 0. So we use AVSeek frame here. And we make sure to flush all the current frames. Currently, otherwise you're gonna get some frames that are still not flushed. That are still stuck in there from another, like let's say from the end of the video, while you're trying to seek into the start of the video. But yeah, that's just a little primer of what's going on here, essentially. Here, look at that. We're opening the video. Then we're trying to find some stream info. So like which streams, and then we try to find the best video stream here, and here you could tell it which kind of stream you want if you'd like, otherwise just say -1. And the related stream, like if you want to make sure to grab the related video audio stream to a particular video stream, then you could put it here, you could put its index here. But yeah, in fact, you could even put a decoder here and it would give you the decoder, but yeah. Here currently we're just doing it manually apparently. So we just grab the stream from the opened, opened format. So streams, and we use the stream as the index there. And here we try to find a decoder from that codec ID of the stream codecs parameters. And then we allocate a packet essentially, and here where we kind of like initialize the Vulkan hardware configuration stuff. And we also have like a fallback for just software. And in fact, for the case of software, I believe we're using multi-threading, right? Where's that part? Yeah, I'm not sure where that part have gone. That's weird. Open codec. But anyways, whichever. So yeah, that's basically it. All right. So let's see. Let's open up OpenCode and let's think about what we gotta implement next. I think I want to implement audio, but I'm not sure where to start there. We'll see. Should we start multi-threading yet? Or yeah, I think multi-threading would make it way easier, because then what we could have is we could have multiple queues of packets, right? And then depending on the dispatcher, which is going to be on a background thread, if it's a video packet that we got, we send it to the video packet queue. If it's an audio packet that we got, we send it to a audio queue, right? Because this is kind of hard to get, right? Because like you got to make another state machine if you don't use another thread, if you just do it inline. So yeah. All right, so read the code. I should have done this while the AI was preparing actually some code, but anyways, I think we probably have enough information to talk about. Yeah, so I have a lot of research to do. There is a lot of stuff that I've found, like a huge rabbit hole. But anyways, read the full code base. It's a minimal Vulkan-based video player. All right, so should we? Okay, can you add audio without synchronization? Because last time I tried to perfect the synchronization from the start and it just blows it off completely. Can you add audio without synchronization? And obviously dispatch the packet depending on which stream it's coming in from one while loop. Tell me first how you plan to do it. Let's see. Yeah, there you go. This is what I was talking about. So basically we have like, if we got a hardware dev device, which means we got like GPU acceleration available on this system, then we use GPU. Otherwise, we just enable the multiple threading of FFmpeg for the software decoder. But yeah. All right. Okay. Yeah, there's this kind of 3 thing there. Nice. Here's my plan. 2 ports, a single demux dispatch loop routing packets to video or audio decoders, fire and forget audio output with no AV sync. Player dual stream decode with 1 dispatch loop in open. After find a video stream, also find the best audio stream. AV find best stream with AV media type audio, and open a software audio decoder, track video stream and audio stream, keep next frame as the single demux loop. Each AV read frame packet get dispatched by stream index. There you go, to the right decoder essentially. Today just skips anything that is in the video stream. Each time a video frame pops out, also drain the audio decoder until EA again into an internal queue. EA flush both decoders. Add a read audio buff cap API that converts skewed frames to interleaved PCM and copies them out. Audio is just a byte stream. I'm not sure about this part, honestly. I believe that's probably not needed with the new like SDL3 stream API, but we'll see about that. Rewind, close, clear the audio decoder plus Q2, nice. Audio conversion. Set up one SWR context from the audio stream params to fixed output, interleaved F32, stereo, 48 kHz, planar, interleaved handled here. This matches the SDL spec exactly, so SDL0 conversion. Okay, so I'm gonna tell it to re-verify the new SDL3 audio stream API. You might not even need lib SW resample. Etc. Push whichever. Read audio returns into the SDL stream. Each frame now sync audio plays. obviously, like the conversion of SDL wouldn't be like, production grade, like something crazy. It would be very simple compared to the FFmpeg implementation, but still, it's way simpler. And should probably do the job. Alright, alright. Let's go. And yeah, let me find a way to arrange these windows. Oh, there you go. And it snapped, I think. Yeah, like, nice. Okay, so how are we gonna do this? Verified against the vendor. Do you write? We can drop and manual interleave interlock. There you go. Look at that. SDL audio stream does all conversion itself, format conversion, channel remap. So as you can see, it would have just added a lot of extra stuff that it doesn't need if I actually didn't knew about the actual API, or at least the new API of SDL audio stream. So yeah, format conversion, channel remapping, and chunk safe resampling. Queued data sets and convert it until the device pulls it. So feeding arbitrary rate channels is fine. Are usually planners, so I can pass extend straight in. Okay, binds the stream in one call. Set audio stream format, since the stream tolerates on the fly format changes. Device starts paused. Player same as before. Instead of an internal queue, hand each decoded audio frame to a sync callback. Sync? I don't think that's required. I don't think you need... Or like, what do you need the callback for? The STL3 new API is streaming, not callback based. Or am I missing something? In fact, you know what? We could do a little thing. SDL3 audio. Category audio. And read this thing, bruh. Read this just in case. And there you go. We just give it the documentation, fresh out of the oven, and we're good to go. Okay, go ahead. This should work just fine because it's a very simple change. Last time I tried to do this, it just like tried to make, making the audio stream the master clock and so on, and it just spit garbage essentially. But yeah. Throw AV. And while it's at it, let's put this guy here. There you go. I used my preset, though I did use the release preset for whichever reason. I never actually tried the release preset. But anyway. But it shouldn't really matter anyways, because we're currently like separating the multiple presets. Every preset gets its own folder, so they don't step on each other. So that's cool. Okay, apparently done. I'm not sure if I have audio. Yes, I do. Okay, let me see. Let me hear if it works. Uh, wait. Bro, what? Nah. Try, well, yeah, that doesn't work. It's overreading or whichever. No, reread the audio code. It doesn't work. I can hear some stuff. What can I say? Into the audio. Yeah, whichever. But audio stream planner data. In fact, I did make a tutorial about this before, but I don't remember how I kind of did it. Default playback, no VGR, call back, resume. So if the FMT is planner, then we put some audio stream planner data. But so this is in push audio. How can I remove this? Sorry. Inline view. There you go. If I still set audio stream format, app the audio stream. Wait. Spec. Okay. And if it's planner, then we put some audio stream planner data, audio stream. Then we give it some frame extended data. And number of channels frame. Yeah, I did had like a tutorial making it, which could have Chaku video player FFmpeg. I think it was probably this one or something.
Ladies and gentlemen, welcome back.
Found it. The bug is starvation burst pattern. There you go. There you go. Here's my previous code, and let's see. I wasn't using Vulkan though. No, dispatch load. Oh, this one I guess doesn't include audio or what? Oh, I guess this is probably another commit. Hold on. Main. There you go. It does include audio. Look at that. All right, well, let's see if whatever it made here would work. So as you can see, using like the SDL renderer, right? Yeah, SDL update UV texture and you're done. But here we're using Vulkan, obviously, so the code is much crazier. Okay. Yeah, I feel like maybe I should just go straight up to multi-threading already. Believe it or not, I think probably like a background thread would actually be way simpler to implement than a single threaded like video and audio player kind of thing. Besides the fact that obviously it's more performance. I'm not sure why the hell it keeps on botching those assistant tool calls. Whichever. Let me just try this now. It doesn't even work. Bruh. Alright. And let me actually just give it that. Let me give it my previous code that I've made, like, I don't know when was that, like, let me see, where's my, where's that thing? Okay, here. Let me actually just grab it here. I'm not sure why it's, I can't for whichever, oh, because it's a private, I see. Hello, the Geeko1, welcome to the live stream. I'm great, thank you, how about you? Alright, so I'm just gonna give it this code that I've wrote, I don't know, like 7 months ago apparently, to the rescue. This code worked for me 7 months ago. Have a look at it and see what you're doing wrong. And it's still compacting the session, dang it. Okay. Alright, so while it's at it, alright, so what's the first of all, what's the format that it used here? Well, I guess it made it kind of dynamic, which is more reliable, but I want to make a video for my application. Do you think making the Vulkan application save back each frame and use an FFmpeg CLI to make a video from that better? Just use OBS, not worth the hassle. A video for my application. What kind of application exactly? Is it your application or an external application or what? I made the GUI framework to draw animations and text. I made a GUI framework to draw animations and text for YouTube video. Didn't like the current options, so I made my own. It's meant to draw shapes and text I need. I see. What kind of libraries you use? Did you use Vulkan, OpenGL, MGUI, what? And what language, etc.? Just Vulkan. Rest I had wrote, used Odin. I see. So it depends. Do you still need the preview? Because if you don't need the preview, then just render to like an off-screen buffer and just say, like, encode those straight to FFmpeg, right? Without going through the window or whichever, without going through the swap chain and stuff. It would be faster, but yeah. Otherwise, if you still need the window, then you're gonna make like a staging buffer. And then you're gonna have to, I mean, it depends on your like FFmpeg, how you programmed FFmpeg. Did you like use hardware acceleration, or are you using just the CPU? Because if you're using Vulkan for the hardware decoding too, then you gotta make like a staging buffer that is meant for uploading the data from the GPU VRAM into the RAM, and then you save that as an image or whichever. But yeah. The old code key is different. It reads back from demuxer in every loop and feeds audio inline. It never blocks demuxing, while the video decoder has buffered frames. My version gates demuxing on AV error and then added on top, which introduced a real bug, is always non-null. It's pre-allocated, so next frame in prime audio we're sending an empty packet to the video decoder. So yeah, this is just like a state machine bug, pretty much, because it's basically trying to shoehorn currently like this kind of you know, iterator style thing, and it's kind of failing miserably currently, but hopefully would fix it now. But yeah. So yeah, it's doing it here, next frame. Can I just CLI and use STB image to save images? I don't mind the time. I have some animations I trigger manually. For example, I select some shape origin point manually, etc. CLI and use STB image. I mean, yeah, I said you would just like create a Vulkan. So are you using like FFmpeg, like Vulkan hardware acceleration, or are you just using the CPU? Like, are you configuring this hardware device thing? Because it depends on how you're doing this. It kind of differs how you save frames, essentially. So are you using this? I don't mind anything, just max quality. Yeah, maximum quality, that's the way you do it. Just tell me, like, are you using hardware acceleration in FFmpeg or not? Because if it's in the GPU VRAM, then you gotta make, as I said, the staging buffer, and you gotta basically make the GPU copy the image of the video into that buffer, and then you basically take that buffer, like you download it from the GPU VRAM, and then you kind of just write that into an image. You obviously you encode that first into a PNG, and yeah, you write it. But if it's just like software decoding of FFmpeg, I believe you're gonna find some easy function to do that, to just in the FFmpeg itself. Just ask Gemini or something. I didn't use it. Still, my basic idea is each frame, copy frame back to CPU, and then use STB image to save to disk as PNG, and then tell FFmpeg here, take those and make. Yeah, pretty much. You would just encode again using FFmpeg. Right. That's the way you do it. So if you're not using hardware acceleration, it's actually way simpler to save back the frame. There's probably some function that would help you in FFmpeg for that. I remember there was like some image API or something. I don't remember exactly, but yeah. Now I'll fix it. The core bug pending package, all instruments pre-allocated. Now the main fix, rewrite next frame. I see. And as I said, okay, hold on. Audio works now. Nice. Look at that. Cool. And yeah, as I said, if you don't need the window, you don't need the preview, the live preview of the process of like exporting into a video, then just don't use a window. Just like render straight to, you know, like an off-screen buffer or whichever. Whoops. Nah, it's working fine. It's working fine. Now just remove the extra code. Alright, so now I think I'm gonna try to make it multi-threaded using FFmpeg queues. And yeah, so that works. Sick. Alright, so now let's implement multi-threading. How about we use what is it called? FFmpeg queues. How do you plan on implementing it? Let's see. So it's opening the audio stream there. And then here, these agents have been painful to use for me. Unless if I have a solid foundation and abstractions, they just do stupid shit. They use malloc inside a loop. I don't let them right now. Unless it's, yeah, it's pretty much, you always gotta know what you're kind of doing. Otherwise you're in trouble. So it's kind of like just hit and miss. But when they work though, they save you a lot of time, a lot of code. But when they don't, but at that point, you know, you just like freaking revert the commit and then just start over. Just try dumping it down again, like just kind of splitting the tasks more for the AI. So it just does mostly the coding part instead of like thinking about how it's going to implement, etc. But yeah, here's my plan. FFmpeg native primitive for this is av thread message queue. Thread save message queue that blocks on full empty exactly what FF places to pass AV packet, AV frame between threads. Video decode thread and audio decode thread. And video decode thread, audio decode thread is main. Okay. AV read frame loop into a fresh AV packet, blocking to the right queue. Yeah, obviously back pressure. You don't want to like overload the memory with a lot of frames. So on AF signal via AV thread message queue, say error send. Video decoder, block and receive video packets. Send packet, receive frame, push AV frame refs. Same for audio. Send equal transfer, receivers free with a queue, free func, AV packet free or tear down flush. So crossing threads is safe, including hardware, AV PIX FMT Vulkan frames. Okay. Lifecycle EOF demox sets error send EOF on both packets. Queue, decode threads drain, then set EOF on their frame queues. Player finished is true and demox done, and both frame queues empty, distinct from no frame right now. Rewind, call that EOF, AV thread message queue flush, all queues, plus AV codec flush buffers. Alright, close set EOF. Alright, so next frame, synchronous blocking. Yeah, that looks good. So which pipeline topology do you want? Full pipeline, decode threads only, or what? 3 worker threads, demux, video decode, audio decode with 4 AV thread. I don't think. How about only for demuxing? Because we already using the GPU for the video decoding. And we are using the wait, what is it called? The SDL audio stream for the audio. So they're kind of async already, right? Also, should we use SDL threads or SCD thread? The video I want to make is explanation of the best algorithm I've found to draw text from fonts, props in Arabic, because we need more content in Arabic. I'll share in Discord when I'm done. Didn't think FFmpeg do audio. Yeah, FFmpeg does audio, does even subtitles, I think, but obviously it just decodes them. You still need like a render like lib placebo that we're currently using here, which is actually Vulkan. By the way, for your render, are you using lib placebo for Vulkan or Lip placebo is like fire. It's pretty cool. It saves you a lot of work. Video I want to make. And yeah, like what you're using for Arabic, like Arabic and like non-Latin characters needs a lot of stuff, like BIDI, I think it's called, or BIDI, or essentially bidirectional stuff, right? And it also needs like text shaping and all sorts of crazy things. It's not really that easy. I guess you're using harf buzz, I think, or what you're using. There's also SDLTTF. So yeah. Just using straight up Vulkan. I do a lot of features. I'm just worried about my GPU, which is good. It's kind of simple. Oh, that's insane. Just using straight up Vulkan. Yeah, I see. You might like Lip Placebo, but I mean, honestly, Lip Placebo have its own kind of like advantages and disadvantages, right? So the bright side, it gives you like HDR and it gives you all sorts of cool stuff and easier time, like setting up the swap chain, setting up. You don't even need the pipeline. You just like give it the file, GLSL file you want to compile, and it just makes the pipeline for you and all sorts of things. So it's pretty good for video media stuff. But on the other hand, you lose control over some things, like which shader language you use. It's kind of hard coded, I think, to GLSL, I believe. And I think they're probably also using their own kind of format too. I guess I haven't played with it yet because I didn't need it so far, but yeah, we'll see about that. I use KB Tech Shape because it's a single header library. Ah, I see. Do they have Odin bindings? I really liked Odin. Makes my life very, very simple. Everything arena, no memory bugs, no Raspberry things. Yeah, Odin is pretty cool. But honestly, since I already kind of know CMake, and I just like to rely on the ecosystem as much as possible for all sorts of things that I'd like to extend or expand on in the future, I don't want to deal with bindings and all sorts of things. It kind of suck. Because while Odin is pretty good, because like it includes most of the things that you'd usually need, like SDL, it includes Raylib, it includes SDLTTF, SDL image, you name it. But on the other hand, if there's something that it doesn't include, I have no clue how you're gonna do it. Because it doesn't even have a build system, so I'm not sure about that part. I've never tried it. But on the other hand, I've already gone through the pain of learning CMake and learning all that crap of C++ and so on. So we're just working with it. I'm not writing the code anyways at this point. So yeah. So nowadays with vibe coding, kind of, my job is just like researching the background of what I'm trying to make in the morning, and at night I just live stream and try to implement what I was thinking about. And yeah, that's pretty much it. So I mean, if I show you right now my research tabs, like my research workspace is full with articles that I want to read and stuff, because I've just gone into some crazy rabbit hole. Because the thing is, what I was having in mind is that imagine some framework that could easily give you like SDL and FFmpeg stuff, right? And like text stuff and HDR stuff, shader stuff, and even AI inference stuff. But here's the real deal. All of these should be in Vulkan, right? So they should stay in the GPU, no CPU readback. Meaning there's no need to use the RAM and stuff. Isn't that libmpv? No. I mean, libplacebo. Libplacebo is actually being used by libmpv. It's using it as the renderer and the Vulkan renderer. And it's also being used by FFplay. So both of these are using libplacebo for their render side. And we're using libplacebo currently too, though that might change at some point in the future. I'm not sure how flexible is libplacebo for my use cases. So far it should probably be fine. Apparently didn't find lib thread message. What? Weird. But yeah, just imagine like a framework, because there's just a lot of game engines right there, but there's no framework for just give me UI, give me media decoding and encoding that is hardware accelerated, give me a hardware accelerated renderer, give me shaders, and get out of my freaking way, right? That's it. Give me text too, obviously. And maybe we could use like Lua or whichever. Or just a library like libplacebo. Those libraries are kind of a pain in the ass to make. So honestly, if I make this, it probably would be using Lua as the scripting language instead. And yeah, it works. So right now I think we're probably like multi-threaded right now. Let's see how it did it. Where do we even start? So we got this main function here. But it's a cool idea if you open source. Obviously, I always open source my stuff. Though it probably might be GPL. I'm not sure. We'll see. I patched the Linux kernel to add NVMe. GPU, no CPU in the way. So maybe I could hook your thing to mine and never touch CPU ever. Yeah, so, I mean, obviously this is just in theory right now, but like, you know, just stitching these pieces together, libplacebo for the rendering part, FFmpeg for the media stuff, SDL for the platform shell for the platform stuff, and boom, and maybe Lua on top for scripting, just like the, I don't remember its name, but yeah, just like that. But yeah. All right, so the cherry on top, yeah, cherry on top. Let's go. All right, so play now. The demux thread implementation is complete and verified working. Summary of what changed. Added std thread, std atomic, and libavutil thread message includes new private state packet queue. So we got a packet queue. So yeah, I remember when I made this in Zig, I actually made my own little, what is it called? Yeah, my own channel abstraction manually. And I could have just used this kind of AV thread message queue, but I just didn't know about it at the time. It was like 7 months ago, or actually before that, I don't know. Is vibecode good for writing shaders? Can you rate output quality? What can I say for that? It's really I can't really like reliably give it like a rate, especially that I'm using here like a free model, so it really ranges too much, right? So my general thumb, so like sometimes it could write for you some very good code, very great code from, you know, one shot done. It's pretty sick. It could even surprise you at sometimes. Other times, it could like surprise you how stupid it is. So it's just like a hit and miss, pretty much. It really depends, but I don't know. I'm not sure if like the paid models are like more reliable on that matter. But yeah, but generally, here's the tips to working with, you know, these kind of like vibe coding. First of all, you gotta understand what you're doing, what you're what you're working on. At least you kind of have an idea of the concept that you're working with. Like, don't tell me you're going to be making like vibe code in a video player and you don't have any idea about how FFmpeg works, or how Vulkan works, or how lip placebo works, or whichever. You gotta know what's up, right? Especially the tools like CMake and stuff. Like, the AI could only get you so far, right? And that's the first thing. Second thing, you gotta dump down. Like, you go one by one, step by step. So you start first, like for example, you start first of all by setting up an SDL window. Then you set up the Vulkan context. It's kind of like you're gonna be doing it yourself. You go part by part, very small steps. And you describe to the AI, and you tell it to tell you what its plan, and kind of follow through and see if it's going to be generating that stuff that is good. Then go ahead, let it generate that stuff, and you can iterate from there, and obviously use source control. But honestly, as much as you kind of, it's also a skill, really. As much as you keep on like vibe coding more, you kind of start to learn and adapt a bit on how to best kind of like operate it, essentially. But yeah, what can I say? But yeah, generally, if you're just starting off, you just want to learn stuff and you need to learn stuff, then just write the code yourself. Don't use AI. Or maybe you could use like the chat app, but don't use an agent. But if you already know what you're doing, and like the AI just would write the syntax and the code and like the math, etc., then go for it, really. And yeah, generally just kind of try to review things. And yeah, that's it. That's my review, I'd say. I tried some WGSL, pretty good, yeah. So sometimes it works, sometimes it doesn't. Depends on how you operate it. So it's really just a skill thing most of the time. And also a bit of luck, I guess. But yeah, there's a lot of cool work around no touching CPU pushed by hardware companies Nvidia and AMD. It's for AI servers, network card to GPU. Oh crap, network card to GPU. I only know about, wait, what was it? Network card. Yeah, there was some passed through that I don't remember what it was about. Like the network card to something. I don't think it's the GPU. Oh yeah. So for example, on Linux, there is like an API call, like system call, sorry, that you basically could literally copy straight from, like inside the kernel, you go straight from a socket, a network socket, to a file. So it doesn't go through user space. Everything just happens in kernel space. So it's kind of like zero copy, right? I don't remember exactly what it was what its name. And obviously you can't do TLS or whatever. So right now I think they also added kernel TLS. I'm not sure how recent that is. And so you can actually right now even do kernel TLS2 in kernel space without touching user space, which is way faster in terms of latency and stuff. But yeah. But network card to GPU, I've never heard of it so far. That's very interesting. NVMe to GPU, NVMe to GPU. I mean, DirectX currently have that. I'm not sure about Vulkan. Did they add that yet in Vulkan? I'm not sure. But I did heard of DirectX NVMe stuff. But yeah. But generally, yeah, I'd love to make some framework that stays as much as possible on the GPU. You could use it to make AI inference, media pipeline stuff, all sorts of cool stuff, without having to worry about like, gluing libraries together and so on. It's just a lot of crap stuff. But yeah, like load from disk directly without copying into CPU RAM from either network or NVMe. It's really cool. Yeah, I'm really fascinated with these kind of like zero copy stuff. It's really cool. It may work with audio too. I think there's a network card to NVMe too. That still uses RAM. Like you copy to CPU RAM, and from there, like you copy to CPU RAM, and from there write to disk. The goal is servers with million requests have less work. Yeah, DirectX thing is fake, but the PC thing is fake. Yeah, I just heard of it, honestly. I've never really tried it myself, so I can't really say. Still copy data to CPU RAM. I see. Yeah, I'm not sure what's up with that. But yeah, all right. So the Dmux thread implementation is complete and verified. Working summary of what changed. It's not a zero copy, but you copy things from card to another. Just CPU doesn't regulate set the framework instead of micromanaging things. Yeah, pretty fun stuff. All right, so open allocates FMT, alloc context, install FMT interrupt callback. What the heck is that? I never heard of that one. That's in player.cpp. And anyways, let's go to the next thing for now. So AV read frame in blocks on shutdown. Oh, wait. AV read frames in blocks on shutdown. Interesting. Allocates the queue, depth 1/28, and size of AV packet. So basically the size of these kind of queues is essentially a balance between latency, the amount of RAM you would consume, or VRAM, I think possibly in this case, if it's like GPU frames, because like you're going to be storing multiple frames possibly if the queue is not empty, and also latency, right? So latency, RAM, and FPS, right? Speed. So yeah, all right. So what's we got here? Dmux loop, single worker thread, AV read frame, blocking, AV thread message queue send, blocking equal natural back pressure on AF error abort, it breaks. And obviously once the queue is full, for whichever reason, if the decoding is too fast for the rendering to catch up, for example, then it just blocks and waits until we have some more space in the channel or the queue. Next frame, same decode logic as before, but the packet source is now AV thread message queue receive. Cool. Blocking. Video packets go to decoder with pending packet. Hold for E again. Audio to the A deck plus drain audio. Rewind. Say abort flag. Wake. Unchanged. Block and receive means null PTR from next frame. Say only happens at true AF, so the existing. Alright, so that's sick. Let me see the code now. Let me actually see the real code here. So we got this demux interrupt CB, which essentially takes that opaque void pointer, turns it into a demux interrupt struct, and it accesses the abort dot load. So it loads that atomic. And it returns that. Okay, interesting. So I guess you return it to basically either quit or not. And then here we got the close function. We just tell all the threads to basically quit, and then we flush all the queues, and then we free stuff pretty much in the close. That's it. As for opening the audio, yeah, just like before, nothing fancy there. And here we set the interrupt callback. Yeah, nothing fancy. And we say AV message thread message queue alloc, and we just give it how much elements to allocate, size of AV packet obviously, and then AV message queue set free function. Okay, so we give it a free function to free the packet automatically. I see, that's cool. And then you got open audio, start demux. So in start demux, what we're doing here, we're just saying if packet queue not equal to null ptr, AV thread message queue set error send packet queue 0. Okay, and set error receive. I think we basically just like clear the errors for now, and then demux thread joinable, then we stop the demux. And then finally, we create a new thread with that demux loop function and this as the pointer. Sorry. And here we got like stop demux. So if demux thread dot joinable, demux thread join. Demux thread joinable join. Okay, and then we got the demux loop here. So as you can see, when it comes to multi-threaded like background thread, it becomes way easier because you don't need to do that weird like async like state machine. So you just do a regular kind of like loop, and then you allocate a packet inside of that thread stack, and then you just read frames and you check for errors essentially. And then here block and send applies back pressure, the pointer ownership transfers, and here AV thread message q send, and we send that AV packet and we're good to go. Receivers drain the queue and set. All right, and here we got the next frame. We push a video packet that was held back while the decoder input was full. Pending packet is a pre-allocated packet, so only send it when it actually carries data. An empty packet would flush the decoder. So we send the packet to the decoder, I think. Yeah. Okay, and then we pull the next demuxed packet, blocking. The demux thread feeds this. AV thread message queue receive. So here we try to receive some message or like some packet from the background thread. We block otherwise. And then if the stream is equal to stream, so basically the video stream, then we send the packet to the video stream, the video decoder, and we're good to, and here we move the ownership from from the raw that we got from the thread, background thread, to the pending packet that we allocated on this current thread. So we just move the ownership here that way. And yeah, otherwise if it's audio, then we send the packet to the audio decoder. And otherwise we drain the audio. And yeah, that's it. Nothing fancy there. Drain audio. AV receive frame, AV frame free, take audio frame. Right. Is STL thread better or worse than STD thread? I'm really thinking maybe the STL thread could possibly give me more flexibility. I'm not sure. Maybe more maturity, possibly. I don't know. The Dmax thread has already exited at EF but joined defensively before touching FMT. Yeah, why not Gthread? I don't think we can use Gthread. Like if it's like the Kotlin or like the Java and like the Go kind of like coroutine or like light threads, then those are just like for IO. I'm not sure if it's the same thing about C++. Why not Gthread? I'm just curious, don't write anything yet. Okay, multi-threaded audio, and let's commit, and let's push. And yeah, we're done with this part. Yeah, so that wouldn't work. I see. Could SDL thread gives us more features or be more cross-platform? Yeah, so actually SDL allows you to basically name the threads. No standard API. It also allows you to set the thread priority and stack size control. SCD thread doesn't allow you to do that. Thread local storage too. Well, we also have like C++ for that too. Sync integration. SDL mutex con same family as rest of the app. Function ptr plus void no lambdas rai lambdas capture. Okay, we'd gain thread names and lose nothing else, but only if we added dependency SDL didn't need SCD thread remains the right fit. Here, swap to SDL thread only if you ever target platform the C++ thread runtime isn't available. What platforms? Where the C++ threading runtime isn't available. I'm just curious. Alright, so I think probably we should right now work on the actual synchronization. I don't think it's... Is it even doing any synchronization currently? I'd love to see how much FPS we're currently like achieving actually. Any mainstream modern target STD thread works fine. Use the RTOS own API there. Still with this platform layer is more like Java port than the C++ runtime. Historical obscure platforms. Alright. Single-threaded WASM. Default encryption builds have no p-threads. Shared array buffer, so SCD thread, and both need the same p-thread plus browser headers to work. No difference, but it shows compiler exists, threading works without setup. Alright, gotcha. Anyways, Alright, so can you like remove synchronization of the video so we're pushing frames as fast as possible? And what else? And switch to mailbox presentation and log FPS every other second or so. I'm just curious how much FPS we're going to be getting from this so far. Otherwise, next what we're going to do is we're going to give it the FF play code because it's like the reference code pretty much. And we're going to tell it to kind of like see how they do the synchronization part, like the master audio stuff, which is very complicated. So definitely gonna let it know. Yeah, look at that. So this is FF play. Let me verify the play placebo present mode semantics before changing it. There you go. There you go, Kodochaku video player. And let's go. So that's how much memory we're using, how much GPU we're using, and CPU. So that's sick. And how much FPS? Yeah, we're getting around 150 FPS for my card. So obviously if you have a better card, you probably would get more. And notice even when I made the picture bigger, it was still fine. It didn't like drop in FPS. Pretty much. And audio is working just fine too. So yeah, pretty cool. Let's go. Nice. All right, so now I'm gonna give it this FFplay reference code, and I'm gonna tell it to see what we need to implement proper audio master clock sync. Plan it out. Here's the reference code. Obviously, we gotta split that into bite-sized milestones so we can debug if anything happens wrong, because sync is so finicky. Obviously also add logs that could help us. Otherwise, I mean, I'm not sure like what kind of stuff does Le Placebo gives us exactly. So here we got Vulkan. Let me pull the reference source so the plan is ground the actual FFplay sync code. Restricts the Vulkan API version. So I think this part of the lip placebo is just like for the context stuff of Vulkan. Pretty much. Allow software, wait. Oh, interesting. Async compute. Disable high bit 10 or more SDR formats may help work around buggy drivers which don't adhere properly when outputting high bit depths. I see alpha bits. Create a new Vulkan swap chain based on the existing. Yeah, import params. Yeah, well, apparently FF Play still uses the old callback style, I see. Alright. Alright, let's see. Here's the plan. Ground the actual FF Play source I pulled down. Master clock, audio by default, everything else corrects towards it. Audio clock, BTS the last good audio frame, minus the audio still buffer not yet played. Today, audio decode lives in line in next frame on the main thread. Demux dispatch into video packet queue. So audio master clock, implement get audio clock via SDL, get audio stream queued. M4, video clock plus master selection, set video clock display, fallback. Okay, constants to port. Should we also implement FF play synchronized audio sample rate compensation via SWR set compensation, or keep audio pristine and correct only on the audio side, only on the video side? Not sure. Full FF play parity. We are, so this only matter, okay. So no need. Video slave only, recommend video only correction for now. Submit. Fine. I don't know why they removed that, like plan mode from the GUI. It was in the terminal tool, but anyways. Alright, so PL Vulkan wrap. Session compacted, alright. Starting M0, let me set up the to-do list and reread the current code state. Allow to transition the image to when holding. So this is basically how you synchronize Vulkan stuff using lib placebo. You have the exact clock implementation now creating sync.h, m0 and wiring sync log scaffold, okay. The semaphore to wait on before lib placebo will actually use or modify the image. And there you go. So we got the clock stuff in one header, which is lovely. So the semaphore to wait on, okay. To wait on before the placebo will actually use or modify the image. See, the lifetime semaphore is indeterminate and destroying it while the texture is still dependent on the semaphores in defined behavior. Technically, the only way to be sure that it's safety free is to use PL GPU finish or similar. PL Vulkan destroy or vacate device wait idle after another operation involving text has been emitted or the texture has been destroyed. Warning, if text is a planar image, now build M0, let's go. It must be a timeline semaphore. Okay, so if it's a planar image, it should be a timeline semaphore. Interesting. Failure to respect this will result in undefined behavior. This warning does not apply to individual planes as exposed by PL textile planes. And I guess it crashed or what's happened there, I'm not sure. And there you go. So it still works, and it should still work because currently it just added like some sync header. But I didn't see anything getting. Oh, there you go. It's all NA, I guess. The type of semaphore to create. Vic is semaphore type. For timelines, the initial timeline value is set. The handle given an out handle. Yeah, the ownership stuff is interesting here. Helper functions to create and destroy. Gotcha. Nice. All right, so that was Vulkan.h for lib placebo. So it will add like an audio decode thread, obviously with their own channels or like their own cues, apparently. Why the hell did they add DQ though? Now the open queue allocation and thread startup. If info has audio, here's the audio decode loop. It receives some packet, it sends it to the decoder, then tries to receive it. I see. Interesting. So now it's in its own thread. It's more drifted off currently, which is nice. Does audio keep flowing? It's like we have water pipes right now. We just clog one pipe and see if the other pipe is still running. Oh, look at that. I guess. I mean, it did run for a while. Let's see. Was it correct? I'm not sure why it's NA though. Oh, but like there is these AFPS apparently. It's nice that we tell it to add logins so we could figure out if what it's doing is correct or not by itself. And it's still thinking. Anyways, let's move on to something else to check on a lib placebo. Because a lot of things are still vague to me when it comes to lib placebo. Okay, did it work? Why the hell did it just stop? So let's go to the next thing. So we got Vulkan here. And we also got these utils libav. And this one is, let's see. It includes the headers of libav format, etc. Cool. And film grain params. No, it failed and exposed a real design flaw. Dropped to 0 and AQ stayed 0. Audio was starved. Root cause the demux thread is single producer for both queues. When the main thread stops consuming video, the delay fails. Oh yeah, so the channel have been filled, I see. I mean, it kind of did this job to some degree, I don't know. This matters for M5, burst of audio, video could stall audio. So video send must be non-blocking, and when video queues full, drop the video packet and keep reading. So audio always flows. I see. The same philosophy as M6 frame drop implement. Interesting. So now if the video is too late, then it just drops back. It doesn't block the audio essentially. So yeah, that works. As you can see, there you go. So if you just implement the whole thing and then something happened wrong, you have no clue, you have no logs, no nothing. It's very hard to pinpoint the problem. And see here, since I've gave it first of all the reference code, and then I told it to like make little milestones, and here it just fixed its own bug. I'm not sure what it did there. And yeah, it even keeps tracks of the video drops, the video frame drops, the audio frame drops, like even the queue, how much stuff inside of it essentially. Interesting. All right, so clean and paste run. All right, so I'm gonna take a little break. Oh yeah, I just like got it. Likely yes, and I know the main culprit. So that's exactly what was happening there. It's missing some BP references because it's dropping a lot of video frames. Lovely. Wait, how the hell did it include Windows.h? Bruh, really? Ain't no way. Okay, so I guess maybe we got something working now. Maybe? I still see some average difference, but yeah, it's cool. That's the master, that's the wall clock, that's the video clock. How much dropped frames, I guess. Like the audio FPS. Fixed. Lovely. The block instant change worked and 5 is now correct. FPS 60 steady was 150 to 5 during the bug based to the clip's rate. Delay consistently. The nominal no more 2.225 second gap. Rock stable. Let's go. Minus 13 to minus 20 milliseconds. Drift. Is the SDL device buffer latency, not drift? Oh, okay. Master tracks real time. Over 9.3 seconds wall. So we got it working. Lovely. Audio cue drained clean. So the video flies by and the code artifacts are both gone. The player now plays real time audio synced within 20 milliseconds. That's M5 done. Next is M6. Frame drop only 8 frames plus edge cases. Okay. Commit the current progress first. Then go ahead. All right, so we've done it. We've done it. Let's go. Okay, so we pretty much got like audio master clock working, so I think I'll just end the stream here. And yeah, there's just some, probably maybe some issue in the rewind that I'm gonna take care of with the agent. And yeah, that was it guys for this stream. Thank you all for watching and see you in the next one. Goodbye everyone. Well, wait a second. But it said something went wrong. Player pushed off FC into SDL within runaway buffering again. Yeah, alright, so yeah, that was it guys for this video. Thank you all for watching and see you in the next one. Goodbye everyone.